This is our video for lesson 5.3. This is solving systems of equations using elimination. So when we talk about elimination, we're going to be adding or subtracting entire equations in order to eliminate a variable. So before we started this section in class, we had a little discussion. If you missed that, so don't copy this down. I'm just going to do a little side work down here. We talked about if you're ordering food at a restaurant and you buy one drink and one sandwich, and it comes out to a total of $4.50. And your friend orders one drink and three sandwiches, and their order came out to $10.50. We could solve this system of equations and find X and Y, which in this case would represent the cost of a drink and the cost of a sandwich. But it must also be true that if I added all of this together, I would get another equation that was still true. So 2 drinks plus 4 sandwiches would have to equal $15. All right, this would have to be true. And this is the basic principle of elimination, just knowing that we can add entire equations together and still get something that is true. That's what we're really doing here, but we're going to do it in a way that when we do it, we get rid of a variable. So in this case, for example, instead of adding, if we subtracted these two equations, we would get rid of that x. So I would probably do this the other way if I was actually doing this as an actual problem. But if we subtracted everything, x minus x goes away, y minus 3y, we have negative 2y, and then $4.50 minus $5, we'd end up with negative $6. And I also wouldn't normally write that 0.00, but hopefully this makes sense as kind of the idea behind elimination. So the steps for this process, we may have to multiply entire equations first, and you'll see why in a future example, but not always. Sometimes we can just go straight to adding or subtracting the entire equations in order to eliminate a variable. And then just like when we did substitution, once we know one, we can plug it into either of the original equations and solve for that second variable. So let's look at example 1. So what we're looking for is matching terms, and in this case it's actually set up kind of nicely. I've got my x's match and my y's match, so we could add or subtract these equations. I think most students generally prefer to add. So if I added everything here just like we did in that previous example, we'd end up with 6x, 2y minus 2y goes away, we get 0, and then 4 plus 8 is 12. So 6x equals 12. And then we just finish solving for x, divide by 2, x equals 6. Sorry. Going ahead of my brain was working ahead of my hand here. We should be dividing by 6, because that's 6x, and then x equals 2. There we go. And again, now that I've got that x equals 2, I can plug this into either of the original equations. So instead of that x right there, I'm going to substitute the 2. So I've got 3 times 2 plus 2y equals 4. 3 times 2 is 6. Subtract 6 from both sides. And divide by 2, you get y equals negative 1. So again, I'm going to go kind of quick in this video, so if you need to pause and kind of process or go back and think through these steps, please feel free to do that. But for time's sake, I'm going to go kind of quickly. So the solution to this system then is x equals 2 and y equals negative 1, or 2 comma negative 1. So remember, if we were to graph this, that would be where those two lines intersect. Moving on to number 2. Again, we're looking for those matching terms. I've got 3x and 1x, so that doesn't really work out great. Again, I've got 2y and 2y again, but now they're both positive, so this would be that case where it might make more sense to subtract that other equation. And if you want to reverse the order of these before you subtract, you could do that too. So 3x minus x is 2x, 2y minus 2y is 0, and then negative 5 minus 1 is negative 6. So divide both sides by 2, you get x equals negative 3. And then we're going to substitute that back in. And in this one, this bottom equation looks a little bit nicer to substitute that in. So we can do that. So instead of x, I've got negative 3. The rest of that bottom equation stays exactly the same. I'm going to add 3 to both sides. So 2y equals 4. Divide by 2, y equals 2. So again, our solution, negative 3 comma 2. Next, here's where, when we talked about those steps in the very beginning, we talked about sometimes you have to multiply. And here's why. My x terms don't have the same number. My y terms also don't have the same number. So I'm going to have to multiply one of my equations to get those numbers to match. And so there's more than one way to do this. There always is. I'm noticing the 3y and the negative 6y. So if I multiply this top equation, I'm going to have to multiply every term by 2 to make it equal, or to keep it equal rather. Then I will have 6y and negative 6y, and I can just add everything together. Okay, so here's what we're going to do. I'm going to draw an arrow here. This is just showing this is what I'm doing. I'm going to multiply that entire equation times 2. And we get negative 20x plus 6y equals 2. Okay, so it's every term gets multiplied by 2. The bottom equation I'm just going to leave the same. And that should be a minus. And I'm going to add these together, again, because I got a positive 6y and a negative 6y. So when I add these together, I end up with negative 25x equals 25. And this works out nicely. Divide both sides by negative 25, because that's what's attached to the x. X equals negative 1. Plug that back in now for x. Doesn't matter which equation. I think we'll just do it in the top one. We've got addition instead of subtraction. We've got 1 is nicer than 23. Either way will work. Negative 10 times negative 1 plus 3y equals 1. So 10 plus 3y equals 1. Subtract 10 from both sides. 3y equals negative 9. Divide by 3, y equals negative 3. Here we go. And then finally, story problems. We're going to be looking at more of these coming up here soon. This is a place where I would definitely pause and try to set this equation up yourself. So read through this, try to determine what your variables are going to be, set up your equations, and solve. So when we read through this, we've got business buying large vans and small vans. You could use different variables. I'm just going to let x equal the cost of a large van, because I know how many we bought. And so if we take however many we bought times the cost of each one, that's going to give us the total cost for large vans. And so then I'll just let y equal the cost of a small van. So we've got our two locations. Location A, I should mention there is a typo in here. This should have been 235,000. And if you were trying this on your own beforehand, I apologize, because that would have given you a completely different answer. So location A bought 5 large vans. So 5x will give us the cost for all of the large vans, plus 2 small vans, and they spent a total of 235,000. $1,000. Realizing space-wise I might end up cramping myself here. Move this over a little. Location B bought 2 large vans and 3 small vans, and they spent a total of $160,000. So that's how we would set this up, and we can solve this using elimination. But what you might notice when we get this all set up and ready to go is there's not an easy way that I can multiply one single equation and get these numbers to match, right? Like 2 times something equals 5. It's not a nice whole number. We could come up with something, but it's not a nice whole number. We could do the same here, right? Like 2 times 1.5 is 3, but multiplying by everything by 1.5 is kind of a pain. So what we can do in this situation is we can multiply them by different things and end up with numbers that match. So if I'm looking at this 2 and this 3, for example, if I multiply the entire top equation by 3, I'll end up with 6. And if I multiply the entire bottom equation by 2, I'll also end up with a 6y. So that's what we're going to do. And then we can just go through our normal process of elimination, and this is going to work out pretty nicely. We're just going to end up with larger numbers than we sometimes like to do. So again, I'm going to multiply everything here by 3. I'm going to multiply everything here by 2. And here's what we would get. We end up with 15x plus 6y equals 705,000. And here we would end up with 4x plus 6y equals 320,000. Now, when we do our process of elimination, both my y values are positive, so I'm going to subtract everything in that bottom equation from the top. We would end up with 11x equals 385,000. Divide by 11 and you get x equals 35,000. So take a second and look back to the context of our problem. This might be another pausing opportunity, and think about, what does that mean now? X equals $35,000. So that tells us that each large van costs $335,000. Sorry, $35,000. So now we've got X. Let's plug that into either equation and find Y. The bottom equation seems to have smaller numbers. So when we plug in our X value, we would end up with 2 times 35,000 plus 3y. So 70,000 plus 3y. The math isn't that bad. There's just a lot of writing because we got really big numbers. When I subtract 70,000 from both sides, 3y equals 90,000. Divide by 3, y equals 30,000, which would be the cost of our small vans.